balancing chemical equations. So a chemical equation shows what is happening during a chemical change. So you're going to have reactants and you're going to have products. In order to balance a chemical reaction, and the reason we have to is because all chemical reactions follow the law of conservation of matter, which means that energy and matter in general is never going to be created or destroyed. So whatever you are starting with in terms of atoms, you have to end up with those same atoms. They may be changed in how they are arranged. So bonds are going to break and new ones will form, but you still have to have the same number of atoms from reactants to products. So in order to do this, we cannot change the subscripts. Subscripts are these tiny little guys that tell us how many atoms are actually combined in a formula. We cannot change that because that's a specific ratio. So we know for hydrogen, hydrogen has one valence electron, and it can only form one bond to get its two. So if I needed, let's say, 4 hydrogens, I can't just change this to a 4 because that would not happen. Hydrogen cannot bond with 3 other hydrogens. So what we're going to do is add coefficients. So a coefficient is going to be placed where these lines are right here. It's a whole number, and it's going to multiply by everything that is after the coefficient. So we're going to practice a few examples on the worksheet, and then you can try them on your own. So this first example right here, this is actually on your worksheet. This is number 4, I believe. If you look at the equation, it says H2, which is a diatomic molecule, which is why there are 2, they're connected, and O2 make water. But look at what happens here. There's an O left over that is not accounted for in this equation. And it's not stable, so that would not happen. You cannot have a reaction where you have atoms left out that are not forming products. So we need to balance this. And in order to do that, I see, okay, if I have 2 oxygens that I'm starting with, I need 2 that I'm ending with. And that's what this 2 is representing right here. But when we do that, we actually make 2 more hydrogens as well. So we started with 2 hydrogens, and now we have 4. So we have to make sure we balance it on this side as well, which is why there's a 2 here again. So this is showing you everything has a bond. Everything is stable with its 8 valence electrons, or like hydrogen, it would have 2. So this is, in essence, what we're going to be doing with balancing. So let's do our first example. In order to balance an equation, you have to have the same amount and type of atoms from reactant side to product side. So I'm going to start by just drawing a line right down where the arrow is. And I'm going to write out what elements that I have present. So I have nitrogen and I have hydrogen. Okay? So on this side, I want to count up what I originally started with. I have 2 nitrogens and I have 2 hydrogens on this side. On this side, I only have 1 nitrogen and 3 hydrogens. So you can see this is not balanced. I have to have these guys the same. So we can start with nitrogen because this is going to be easiest to balance. Because remember, when we add coefficients, it's going to multiply by my subscript. So I can multiply a number by 1 to give me what I have on this side. And that number would be 2. So I'm going to put a 2. This is my coefficient. The 2 goes in front of the n. Now, whenever you place a coefficient, you need to recalculate your number of atoms because that's no longer true. So I have 2 times 1, which is 2 nitrogen now, and 2 times 3, which is 6 hydrogen. So I actually changed my hydrogen too. So now I have to say, okay, my nitrogens are balanced. What am I going to do to balance my hydrogens? Well, right now I have a subscript of 2. What is there, first of all, is there a number that I can multiply by 2 that's going to give me 6? And there is. So it's going to be a 3. We're going to place it right in front of the H, and we're going to cross this out and recalculate. Now, did my nitrogens change? No. So I'm going to keep that 2. 3 times 2 is now 6. So this is balanced. So my coefficients would be 1, since I didn't write anything, 3, and 2. And this would be a completely balanced equation. So let's try another one. The next problem is KClO3 produces KCl and oxygen. So let's put our line right down the center, or in this case, it's not the center, and it's actually probably not going to be the center. You're going to put it down the arrow. And we're going to take our count. So I'm going to write out the elements I have. And you're always going to have the same elements on both sides, or it's not going to be written right in the first place. So we wouldn't be able to balance it. So Cl and O. On this side, I have 1 potassium, 1 chlorine, and 3 oxygens. On this side, I have 1 potassium, 1 chlorine, and 2 oxygens. So in this case, these guys are already balanced. The only thing that's not balanced is O. Now, usually, if we have O involved, and we usually do have oxygen involved, we like to save it for last because it's kind of a pain. It likes to show up in multiple molecules in either the reactant side or product side, and therefore, when we change it, we have to wind up changing it again. So I'll show you that in a later example. So this case, we have no choice. We're going to use oxygen first. So I got to figure out how I'm going to get these two the same. Now, is there a number I can multiply by 2 to give me 3? No. Is there a number I can multiply by 2 to give me 4? Yes, but I can't multiply anything by 3 over here to give me 4, so that's not going to work. And neither of these can multiply by anything to give me 5. So I need to make both of these 6. Okay, so how am I going to do that? Well, my 2 has to be multiplied by 3 to give me 6 oxygen. That's the lowest number that I can make both of these sides because I have to use whole numbers. So when I put a coefficient, I cross out and I recalculate. So I have 6 oxygen, and this didn't change, so I still have 1 and 1. So now I can go ahead and finish up with the oxygens, and I would need to put a 2 here because 2 times 3 would be our 6. Now, I did actually change my potassium. I changed this to 2, so it's 2 times 1. 2 times 1 for chlorine, and 2 times 3 is 6 for oxygen. So now these guys are unbalanced. So I'm going to balance them. What would I do? So they're together in this compound, potassium chloride. So whatever I put in front of the potassium is also going to multiply by my chlorine, which is great because I need them both to be 2. So I'm going to put a 2 here. So I cross out and I get 2, 2, and 6. Everything matches up. So these would be my coefficients, 2, 2, 3. And our numbers have to be the lowest possible coefficients they can be. So therefore, if you come up with an answer and it's balanced, but it's not the simplest answer, you would have to simplify it, just like you would an ionic formula. Okay, let's try another one. So we have NaCl plus F2 gives me NaF plus Cl2. And I'm just going to point out here that these guys are part of your Brinkelhoff. Those are your diatomic elements, which is why you see them as pairs. So I have Na, I have Cl, excuse my writing, and I have F. Now, it's not in the same order on this side, but it doesn't matter. I want to keep it the same. It doesn't matter what order it is, but you have to make sure you count up the right atoms. So I have 1 sodium on this side, 1 chlorine, and 2 fluorine. I have 1 sodium, 1 fluorine, make sure you put it where F is, and then 2 chlorine. So now I have to balance. So looking at this, sodium's already balanced, so I can leave that. Chlorine is not balanced. I have 2 on this side and only 1 on that side, and fluorine's not. I have 2 on this side, 1 on this side. So either one of these I can start with because they're going to be equally as simple because I'm just multiplying 1 by something to give me what I have on the other side, which in this case would be 2 for each of them. So we can start with chlorine because that comes first in this list. So I would have to multiply this by 2 to make 2, and that would balance out. So when I do that, I actually change my sodium to 2, chlorine to 2, and F is still 2. Okay? Now, I can continue if I want and do my F like I said, and actually when I do change my F's to 2, I'm going to wind up changing sodium as well since they are together in a compound here. So what am I going to multiply by my 1 subscripts to give me what I have here, which is 2? Another 2. So that's going to give me 2 times 1, 2 sodium, 2 times 2, which is 2 fluorine, and I still have my 2 chlorine. So now everything is balanced, and these are my coefficients, 2, 1, 2, 1. You do not have to put the 1. Let's go to a little bit of a harder example. So for this example, we have AgNO3 plus MgCl2 gives me AgCl plus MgNO3 too. So we have a polyatomic ion here. Now, you can keep your polyatomic ion together to balance if it stays together from side to side. So for example, I have NO3 right here, and I also have NO3 right here. So I can almost treat that as if it was one element. The other option is you can separate them and do N and N, O and O separately. So I'll show you both ways. Let's split this down the middle. So we have AG, we have N. So first I'm going to split them up. I have O, I have Mg, and I have Cl. So I have a bunch of elements here. And just because I have a lot of elements doesn't mean it's necessarily going to be harder, just to give you a heads up. So we have one silver, we have one nitrogen, we have 3 oxygen, 1 magnesium, and 2 chlorine. On this side, I have 1. Nitrogen is 2 times 1, which is 2. Oxygen is 2 times 3, which is 6. I have my magnesium is 1 and chlorine is 1. So looking at this, we have a couple of things out of balance: nitrogen, oxygen, and chlorine. So we said, remember back before, that oxygen's usually going to be the one we worry about last. So I'm going to worry about nitrogen and chlorine. And you want to pick which one's easier to solve first. In this case, they're both equally, again, as simple to solve because they're both going to become 2 from 1. So you can start with your nitrogen if you would like. So you would put a 2 here because this is where nitrogen is. Now, I have to recalculate this side because some things are going to change. 2 times 1 is 2 silvers now. I have 2 N's now, and I have 2 times 3, which is 6 O's. I still have only 1 magnesium, and I have 2 chlorine. So in doing that, I actually balanced my oxygens out. So now I have silver, though. So I balanced oxygen, but now silver is actually not balanced, and I still have chlorine. Now, looking at this side, I can balance them both at the same time because they're both in this compound. So since this needs to be 2 and this needs to be 2 to match up the reactant side, I put my 2 here, and I'm going to recalculate, and I have 2 silvers. I have my 2 chlorine, so that's down here. I still have my 2, 1 times 2, which is 2 nitrogen. I have my 2 times 3, which is 6 oxygen, and I have my 1 magnesium. So everything matches up. So my coefficients would be 2, which is right here, 1, 2, and 1. So that was taking everything separately. Now, let me clear this and show you again, treating this polyatomic ion as one element, okay? Even though it's not, we're going to treat it like that. So I'm going to do Ag. We have NO3, so I'm going to keep that together. Then we have Mg and Cl. So 1, this is 1 NO3 because there's no subscript outside parentheses, so there's only 1 of those. 1 magnesium and 2 chlorine. So I'm just eliminating another element because I put N and O together. Now, I have 1 chlorine, which is down here. I have 1 magnesium. And do you see in this case, I have 2 of this nitrate ion. So I put a 2 here. So looking at this, it's just my nitrate and my chlorine, which are not balanced. So to balance my nitrate, I got to have 2 of these. I just put a 2 in front because that's going to make 2 N's and 6 O's, which is going to actually be the same as 2 NO3s. Okay? So I'm balancing it, just keeping this as if it was one element, even though it's not. So I'm going to erase this. This is a 2 because I times it. This is a 2. And then this is still 1, and this is still 2. So now I, again, unbalanced my silver, and my chlorine still needs to be balanced, and I would do the same thing. I would put a 2 here, cross these guys out, so I have 2, 2, this is still 2, and this is 1. So it's the same thing. We get the same answer, 2, 1, 2, 1, but we just did it in a little bit of a different way. Okay. One more example, and I want to do this example because this example has oxygen in 2 different places on one side, and that's why we save oxygen for last. So if you notice my products right here, I have oxygen here and oxygen here. This is when it gets a little bit tricky. You have to make sure you add these together. So we have carbon, we have hydrogen, and we have oxygen. So it's not going to be crazy difficult, but this is going to be one of the ones where you have to just be careful. So I have 1 carbon, 4 hydrogens, and 2 oxygens. On this side, I have 1 carbon, 2 hydrogens, and now this is a part where you have to make sure you're careful. I have 2 oxygens here, but also 1 here. So there's a plus sign separating them. It's 2 plus 1. I actually have 3 oxygens on this side. So what am I going to do? Now, in this case, we have hydrogens that are not balanced and oxygen. So we always want to save oxygen for last if possible because it's going to be a pain in the neck. So what I'm going to do is I'm going to try to balance my hydrogens first. So what am I going to multiply 2 by to give me 4? 2. So I'm going to put my 2 in front of my H. 2 times 2 is going to be 4, so this is going to change for me, and that's what I wanted to do. Still 1 carbon, and now let's check our O's. We have 2 plus 2 times 1. So what I like to do sometimes is, let's put my count up top so I don't mess up. So I have 2 O's on this side plus 2 times 1. Remember, there's a subscript here, so 2 times 1 is 2. So I actually have 4 oxygens. So I balanced out my hydrogens, but my O's are still, my oxygens are still not balanced. And now it's actually easier to balance because now I have a number that I can multiply by to give me what I have here. So since I have 2 oxygens here, I would just multiply by 2 to give me my 4. And this stays 1, this stays 4, and this would be, oops, sorry. Undo that. This would be 4. 2 times 2 is 4. So this would be 1, this would be 4, and this would also be 4. So everything's balanced. So it's 1, 2, 1, 2. So those are all the practice problems. So go ahead and try the rest on your own.